So I'm just going to take you through some of the applications that we're using drones in now. It's not exactly a new science. It's been done for years with a lot of quite large-scale sites with planes and satellites. The technology has just become small enough and applicable enough to use it on drones. When I talk about drones, I don't always necessarily mean what most people are used to as small drones. The image on the right is some of the drones that we fly in the UK. We tend to fly in this company 26 different types of drone. Most companies will fly 3 or 4, so we become real big specialists in it. The drone is just a taxi at the end of the day. It gets the sensors that we need into the places that we want them. A lot of the sensors that we work with are things like RGB, or as we would all know it, cameras and visuals, ultraviolet, hyperspectral, LiDAR or light detection and ranging, thermal imaging, even ground penetrating radar to some extent, optical gas imaging, and other forms of gas detection. One of the things that makes it quite unique in my job here at Texo is they have one of the most expansive cases, which means we can operate across a multitude of sectors and areas. So conceptual site models for us have evolved from places such as new field development, brownfield development, to things like oil and gas, nuclear, even renewables. Initially, what clients come to us for is initial assessment, and it's something that isn't new. I mean, the first recorded drones is 1858. They strapped a camera to a balloon and set it up and got a picture. And it doesn't sound a big thing, but at that point in time, it was groundbreaking. And since then, it's really evolved. What we're using drones for is the initial visual assessment of sites, like the image on the right for a new environmental campaign. What we're doing on the top right-hand image is assessing the before and after of a new flood defense scheme going in. We're looking at the potential stakeholders and things that need to be engaged in, what the land use is currently, what the other hazards are. And this is all land that no one's even approached the landowners to buy yet. It's just in a conceptual stage. We use it to do things like identifying information at height. One of the jobs that we just previously carried out was on a nuclear refinery. They had a furnace, and what they need to do was understand if there was any material at the top of the stack. Because when the stack was demolished, this now becomes quite a dangerous radiological contaminant, which can get straight into the water system running adjacent to site. Other things that we work with is confined space inspections. Often we're called in to fly drones into caves or tunnel networks to identify where the ingress of a contaminant is coming from, and often the pathway that it's taking. Things such as man-made excavations, shafts, pipelines act as pathways, and they often exacerbate and speed up the transfer of these contaminants across a site beyond what people are prepared for in their initial models. We also take this data and we feed it into advanced 3D geospatial processing and data generation, which is what Richard Short had touched on earlier. Aside from the 3 main forms that are being used, clients are getting smarter with their data. They're looking for new ways to represent it and give this kind of real-world feel to what they're looking at. It helps them understand the interaction on their sites. One of the other things we're feeding is things like live streaming. So the image on the right here, what you're seeing is the little yellow thing is one of our drones deep in the fjords of Norway. We've got a retrofit to what we call a semi-sub, which is basically an oil rig that floats. They're taking apart some of the storage tanks, and they need to monitor what pollutants are going into the water, if any. There shouldn't be. And unfortunately, what you can see just in the top left corner of this image here is an oil slick forming. So it's not just building that conceptual, it's also helping monitor, it's helping give live reactive data to people. And I mean, this data from Norway was streamed live to their offices in Stockholm. I think they're based in Stockholm, actually, on this one, and the UK. When I talk about that kind of 3D geospatial kind of development, what we're using is things like photogrammetry. Before clients are even purchasing sites, they're wishing to understand some of the geomorphology of it. They're wishing to understand what's physically held on that asset. So the top image here you can see is a brownfield development. The clients asked us to go in, utilize drone technology to help them identify potential hazards in the desktop study for their team. What we're then delivering is other sites like the bottom right here, where we're developing what we call auto mosaics. These are, as described by some of our clients, Google Earth on steroids. If you have your boot open, we can zoom in and read the number plate and see the screw type that's in the back of your car. It's very, very high detailed. We're talking some of our images get down to about 0.3 of a centimetre per pixel. So it's very, very good imagery. It's up to date. It's instantaneous, and it's a very cost-effective solution for a lot of people to utilize in their initial recce. What it means is, and I'll talk you through examples here, is this entire cliff surface here at Dartford is a new development, 3.5 kilometres of cliff, and what we're looking at is pollution ingress from the road above, potential fractures, faults, pathways. the level of detail we captured along that whole model was the same. So the geologists, the environmental team, everyone can sit behind a desk and go through every square inch of that rock face without actually having to trudge down to site. And I can assure you that site is particularly painful to get down. I led the campaign about a year and a half ago, and we had to get pulled out with a tractor. It's carnage beyond belief. They're pumping out the equivalent of 4 Olympic-sized swimming pools every hour out of that to keep it dewatered until they can put in the remediation methods. It means we're doing things like this. So the image in the centre here is an old mining site down in Cornwall. Historically, it's been maintained with the attitude of let's just leave it lie. What the team have realised is they can't do that anymore because they're looking at developing around those areas. So what we're doing is developing images like the top left, which is digital surface models. These actually give them the topography of those areas. It gives them the surface runoff. It gives them drainage channels. It enables them to identify these pathways. What that blends into is images on the right, where the drainage ditch on the right is for agricultural. The drainage ditches on the left is from said mine site, and they've got Fe3+ contamination in it. So what our job was to do was go in and aid the team there to develop this site model, to identify where this Fe3 leachate was progressing into the water column, and also identify where it was leaking along this bounding wall here. So somehow along this entire 2-kilometre stretch, there's a break in that wall, and it's leaking into the agricultural reserves. And on the other end of the scale, we do things like new brownfield development. We will go into historic gas holders like this one, document them, allow the client to have the virtual walk around, but allow them to identify particular hazards at height. One of the things they weren't aware of is the top sections of these box units have an asbestos coving. So traditionally, no one would have known until they'd blown the tower and let it drop onto the ground and get spread across the entire site. The use of drones enabled them to get up close and do the visual identification. And again, it's not just the developments. We're working with mining companies at the bottom right here as well to help them understand what kind of volumes they're removing from site and where the contaminations are coming from their sites into agriculture. And when we talk contamination, we're not talking about heavy metal, we're talking about aggregate. We're talking about sand and particulates getting into water column and causing sedimentation, which is having a negative impact on the wildlife. So there's a number of areas we're working with key clients from to help support them and help support their CSM. CSM for a lot of our guys isn't just before they buy the site, they maintain it through the lifespan. So like Richard alluded to, when you're finding problems, you're filling the gaps. One of the further tools in the arsenal for some of our teams is LiDAR. So light detection and ranging is a very powerful tool. It's got kind of the unique ability to penetrate through tree cover, as you can see in the image on the right, which means you've now got a very, very good understanding of what's going on in that forest area, which if anyone's ever tried to do a ground survey through heavily vegetated woodland, it's an absolute nightmare. I spent months trying to get through a small hectarage of site to try and identify spore heaps under vegetation, and you miss most of them. They're only exposed once they've deforested that area for the development, and by that point it can often be too late. Clients and stakeholders have committed resources and there's expenditure beyond the budget that goes into costly production. So again, this thing's looking after the stakeholders. Really good example here, one of our sites, a massive new build construction firm in the UK, and we will go assess their sites before they even buy them. We will rock up to the site, fly the LiDAR drone over it, and we'll measure 1 million points a second. And what you can see is the image on the left is the forest that they want to rip down and develop in. The image on the right shows the bare earth as if you burnt every tree, every blade of grass off it. What you can see in the top-hand corner of that site is a rather nasty stockpile that no one was aware of. Water monitoring on the site revealed heavy metal contamination, and what you've got is a small stream system running through here. The site was historically used as a military test range. Think 1700 sort of cannonballs, gunpowder laying everywhere. And what you're actually viewing there is a spore deposit from all the offcuts from the cannon fire, all the removed gunpowder, all the heavy metals, everything was piled into one part and left. So the client not only had an idea of what was under there, they sent teams in to take small samples. It was a targeted approach. And it meant that we could quickly, at the click of a button, give them the exact volumetrics of that pile. How much land did they need to dig away? How much did they need to do contamination relief on? To give you an idea, we kind of take all this data And this is where the clients are getting smarter. They're using things like our online portals. They're using GIS software. They're measuring themselves. They're going through and doing cross sections like this, where you can see the undulating fall of the land. You can see drainage ditches. You can see the tree cover. You can see the different banking walls, things that previously weren't seen. So they're getting a real understanding of how surface runoff can affect their models. Contaminants ending up in places they weren't aware of because they're not aware of a great big soil wall running underneath a forested area. And again, it's not just that. We're talking, the building here is a heritage structure. It's also heavily contaminated with knotweed. So the client's now got to figure out how much of that site is inhabitable by the development, what they're going to do to contain it, how they're going to manage it. And this is key things that these kind of dimensional models give them information on. I'll just skip ahead a little bit there. So the same model, I mean, this is 20 hectares worth of site and it's captured in 28 minutes, processed out the next day. The points you're looking at are, I mean, here you'll see the stockpile, as if you've walked around with a GPS rover and taken each one of those. And normal survey, I mean, that's what we do traditionally. You're getting 1 point every 2 to 5 meters. Dealing with this kind of data, you're getting 800 to 900 per square meter. So it's very, very accurate. You're able to delineate your spoil heaps very accurately, and you're able to pass on that information to clients. That being said, not all clients are that techie. I work with a lot of construction companies where you rock up and their laptops are 15 years old and they're about ready to throw them out the window. So we translate this into stuff they can use, digital surface models on the left, traditional PDF outputs for contours, vegetation outlines. And what you've got here is this drainage ditch running along the right hand of the site, acting as a pathway for fertilizers into a local watercourse. It shouldn't be there. Farmers dug it to try and act as a water reservoir for himself, not understanding the impact he was having further down the water system. Confined space surveys is something that a lot of people don't consider with new build sites. Yes, the client may have gone ahead and bought the site, but they can't actually get into a lot of these buildings to assess the materials that are in them. What we're looking at on the right-hand side here is a top right image is an underground network of smuggling tunnels in central, oh God, I can't remember now, it's testing me a little bit. The drones were sent down to uncover what was in there, what the effect it was going to have, and actually noted that we were getting discharge from this wellhead here from a local chemical factory by accident. It's all historical stuff, but it's still stuff that feeds into the model for them. The bottom image on the right here you're looking at is a disused train shed. Now, you can't send personnel in. It's listed. It's buried in a forest. No one's known it's there for 10, 15 years, but apparently it's got a listing. So we can't destroy it. We've got to figure out how to manage it. What we do is send little vehicles like this in with laser scanners, and then we send drones in to fly up into the rafters and assess what's going on. Same drone here can be seen going into sewage silos and things like that. Client is quite a prestigious client for the new Commonwealth Games. And what they need to understand is this storm drain, what's happening, is there new runoff coming in? And you can see from the thermal straight away it is. If it was old runoff just sat there, it would all be the same colour. The client's not aware of this. Someone's built a bricked archway going into their runoff into the local river. This shouldn't exist. So what we've now done is take that visual data, and what you can see on the left is the drone's actually being tracked afterwards, showing its position in X and Y. We know where it is. We know what it looks like. We can take the images, and then we send the drone in and we 3D model it. So the client's now able to understand, actually, there's one network of pipes here we weren't aware of, and then we go over the wall and there's a second one they weren't aware of. So this storage tank has the potential to cause damage to 2 different offloads. And you can see from the debris that the water is getting that high. This was quite a nasty one and quite an embarrassing one for one client. They couldn't figure out how contaminated material was getting onto their site. So this is a 240 kilovolt set of cables, 4 of them running next to us. The roots have broken in, opened up the pathway in the shell casing, and the water's leaked in and is being pushed, I think, 2 kilometers downstream to another site, and then it's getting out at another leak point. So this is all targeted investigation afterwards. Clients are seeing the initial outputs from the CSM and wondering where this stuff's coming from. And lastly, we have something called hyperspectral. So this is seeing more than the eye can see. We see in red, green, and blue. These cameras see across the wavelength of electromagnetic spectrum. It's a very, 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 very good tool for mass data collection. It's not standalone. You need to do ground truthing. But what it means is, instead of, as you can see there, the black dots, every pixel in that image becomes a test sample site. So what we've got here is an Fe3+ contaminant in the mining. What we're looking at for the client is this bank here from colour, they assumed it was Fe3+. They also assumed this large amount of material was. From the ground contamination model, you can see here that actually all this material here isn't Fe3+. It's just clay-rich soil. So the client's saving tons and tons and tons of remediation material not being required for this project. It's not just things like Fe3+ we're turning to. We can use this for things like invasive species identification, mineralogy of soil complexes. You can pair this up with a very good ground truthing regime to give you very accurate data. It's mass data collection at its finest. It's also historical documentation. I spent the first part of my postgrad when I left university reinterpreting old historical data from spectral imaging. You've got multiple analysis. The item you're looking for might not necessarily be what someone's looking for down the line. They can also investigate that. And it's a great support tool for surface investigations. These are kind of the systems out there that you can work with. Most of you guys will be working in the SWIR region, which is for your mineralogical compositions. NEAR and VNEAR is sort of more vegetative stuff. So we look at it for vegetation impact. And just to finish off nicely here, you've got a couple of slides for some conceptual sites. So again, the same one from the mine site on the left, bottom left, the drone in the middle, the site on the right. And the top one here, what we're actually looking at is a heat map of invasive species along a track section. It's quite scary when you as a client think you're trying to develop this site and everything in orange on this bit here on the right is knotweed. So that's something that the client's pulling out of the deal on because they've realised they're not ready to engage with that. It's something that all the key stakeholders in that area have been made aware of and now they can actively track. Brilliant, and that's sort of everything from us. If you've got any questions, just feel free to fire them over to me.